this video I'm going to show you how to calculate the Pearson correlation coefficient. So we're going to work with some data that was introduced previously in the last lecture. So this is data from a fictitious study in which we've got two variables, right? So we've got a sample of people. So if you look in this column, it says person. These are our folks. Were measured on two different variables. One of these variables was family income, and the other was student's average grade. And we talked about how you would plot this data and kind of to visualize it and try to eyeball whether or not there was a correlation there, whether it's positive or negative, and how strong it is. And so I think clearly this data clearly indicates that there's a relationship between these two variables. The relationship seems to be a positive one, positive correlation. It looks pretty strong, right? But we have to go beyond just eyeballing and quantify this, right? So we can be a little bit more precise in determining the strength of the correlation. So we take the data, and you'll do the same thing in your homework problems. You can take the data and you're going to dump it into Excel. Okay, so I've already done this. I've just opened up Excel here and opened up a brand new sheet, and you can recall we worked with this in class a bit. It's very intuitive. You can just highlight a cell and start typing in it and enter your data. And so I entered the data from these two variables in an Excel spreadsheet. And to calculate the correlation, the Pearson correlation coefficient, is very easy. Remember, anytime we start a formula in Excel, we first start with an equals, the equal sign. Okay, so that should be up in your top right somewhere. So we're going to equal sign, C-O-R-R-E-L. So equal sign, C-O-R-R-E-L, open parenthesis, and we're going to select one of the variables, start in this top cell here, and we're going to select all of the data in the first variable, family income. So this is going to be C9, and that's a C22. Right, that's C22. You can see we've got C9 to C22 there. So you can either type this in manually, or you can select this cell and you could pull down, or you can hold Shift key on a Mac and then select 31 and 174 while holding Shift, and it will select all of the variables, values for you. However you do that, you just want to make sure you select all the values. Then you're going to put a comma in. You're going to select the next variable. That's going to be D9 to D22. So here's D, here's 9. So you want to get that 72. Here's 22, and you get the 95, and you're going to close the parentheses. Okay. So now we just hit return. And we've got our R value. There it is, 0.65. Now, as you can recall from the last lecture, we talked about Pearson correlation values as existing on a continuum from -1, that's the perfect negative correlation, to +1, which would constitute a perfect positive correlation, and then any value in between there. So 0 and 0 would reflect 0 or no correlation. So a 0.65, and our value of 0.65 is a pretty strong positive correlation. Right? And that looks about right, looking at the data. Okay, so we're looking at a pretty strong correlation there. There's one other thing we want to do. We want to know if this is a statistically significant correlation, right? So similar to when we were looking at means and comparing means, we might see two sample means with a slight difference between them, right? Suggesting, there might be an effect of some independent variable on something we were measuring. But we don't know for sure that this is a difference that goes beyond just what we might expect based on sample error until we conduct a significance test. We did hypothesis tests when we were doing independent samples t-tests. We do something similar when we're doing correlations. It's just to derive a t-value and then ask what is the probability of obtaining a t-value this high if the null hypothesis is true and there's no relationship between these two variables, right? What is the probability? And we'll use the same threshold as we did before, which is 0.05, so p equals 0.05. This is also very easy to do. So we've got our R value. We're going to take our R value. I'm going to copy it, actually. So I just command copy there. And we're going to go to the web now. And you're going to be looking for a website that is hosted by Vassar. And you could type in this web address right here, or you go to Google and go to Vassar significance correlation coefficient, and Google that phrase, and it'll be the first, should be one of the first findings that comes up. And this pops up a significance calculator for correlation coefficient. Okay, this is going to give us a t-value, and then it's going to give us a p-value. It's going to give us the probability of obtaining a t-value this large for our correlation if the null hypothesis is true. And we're looking for a value then, the probability value of less than 0.05. Okay, so let's. I think I copied the correlation already. Plop it into this. There it is. So R equals, boom, we plop the correlation value in from Excel. N is going to refer to the number of participants, right? So let's go back to our Excel file here. This is referring to the number of people. So these are our people right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we're going to go back to our calculator. And we're going to put in the number of subjects. We can put in the degrees of freedom. Actually, it's going to calculate the degrees of freedom for us, so I'll talk about that in a second. So we've got N and we've got R, and we just hit calculate. And there we go. I've got a t-value of 2.968. We've got degrees of freedom of 12. When we're doing correlations, you have to subtract 2 from N to get the degrees of freedom. Then here are p-values. So whether it's a directional hypothesis, which is similar to a one-way hypothesis, right? So we're just predicting a correlation in one direction, so just positive or just negative. Our p-value is 0.005. So we would say that this is a statistically significant correlation because it's less than 0.05. The probability of obtaining a correlation this strong, finding a relationship this strong with this many people, is very small. It's less than 5%. Even when we do a non-directional hypothesis, we still end up with a value that's less than 0.05. So just a little bit above 1% probability for a non-directional hypothesis of obtaining a correlation this high, this strong, if the null is true. So we'd say this is evidence that there is a statistically significant correlation here. Okay. So we might go back to Excel then and say, okay, well, let's just get all this info here. We've got N of 14, we've got degrees of freedom 12, and let's say we do the non-directional hypothesis, so similar to the two-way t-test, 0.011744. This is more decimal points than we need, but take it anyway. Okay, so that's how you would conduct, you'd first compute the R value, and then test whether it's statistically significant. Okay, one last thing is if you're not able to get onto Excel, you can go to Google. Log in with your Google account and go to Google Sheets. Okay, I'm actually on Docs right now. docs.google.com/spreadsheets. But if you go sheets.google.com, it'll take you to the right place. So it'll take you to Docs, Google, Spreadsheets. And then you just open a blank spreadsheet. Okay, and you input the data into Google Sheets just as you would into Excel. Right, you name it, grade, and then you also use the same command. So equals sign, C-O-R-R-E-L, open parenthesis, select all these, comma, open parenthesis, close parenthesis, oops, C-O-R, I've got an extra R there, R-E-L, and there's our value, 0.6506389, it's the same value, okay? So you can go to Google Sheets, and then you could go to the calculator and just input the data, input the value. This is a different one here. Let's go ahead. And there's your p-values, there's your t-value, and your degrees of freedom. So that's all you really need to do for the homework, is to be able to take data, calculate a correlation coefficient, and then test for whether it's statistically significant or not. right? And then the first two videos are really meant to help you understand conceptually what's going on with correlations, understand how to identify positive and negative ones, whether something's linear, nonlinear, and then identify its strength. And now by quantifying it based on the Pearson correlation coefficient, which you can compute using simply using Excel, okay, or Google Sheets. And then finally you end up at Vassar Stats, where you plop these values in to test whether it's significant. And that's it. Done deal. Okay? So that'll get you through the homework problems we're meant to do. And this will prove to be a useful statistic to be able to calculate in the future. Okay, so that's it.